Good morning. Good morning, all. Yeah, so let everyone join. So by that we will continue our lecture. Okay. Okay. So let me share the screen, guys. Yeah. Guys, can you see the screen?
Sir.
Yes, sir.
Okay. Yeah. So actually, yesterday we are discussing about how to calculate the stresses, right? So one is the hoop and circumferential stress, and the other one is the longitudinal stress. And as it is a thin cylinder, so we are neglecting the radial stress. Okay, so which is gonna important in thick cylinders. Okay, right. So let's see, and 1 second. Okay. Yeah. So actually yesterday we are calculating how to calculate the circumferential stress formula, right? So we have done a small derivation. So where we are going to calculate the bursting force across the diameter of the section. So first, for calculating the total bursting force, we have to calculate the force on the elementary area, right? So in that way, we have calculated the bursting force which is acting on this elemental area. So by taking length as a dl and elemental area is dA. Okay, so this is your bursting force which is acting on the elementary area, which is P into what will be the elementary area, which is the d by 2 times of dl into d theta. Okay, so horizontal component of this force. So we are going to distribute this force towards horizontal and vertical. Why? Because this force is gonna act in terms of resultant. Okay, this is your resultant bursting force, so which is gonna split that force into horizontal and vertical with respect to angle theta. So when you distribute this force with respect to angle theta, so that horizontal force will be P into d by 2 into dl into cos theta into d theta. And what will be your vertical force? Vertical force will be P into d by 2 into dl into sin theta into d theta. Okay, so that is what we have done in the previous class. And then out of these two, horizontal and vertical force, which force we are supposed to consider for calculating the overall bursting force? So because in this horizontal and vertical force is going to make a bursting in the vessel or in a cylinder. Okay, so by that the horizontal components cancel out when integrated over semicircular portion, as there will be another equal and opposite horizontal force. So that is the reason why we are going to neglect the horizontal force, and based on the vertical force only we are going to calculate the overall bursting force. Okay, so let us take total bursting force. So when you have an elemental strip, so when you want for the overall section, what we have to do? We have to do the integration, isn't it? So integrate that elemental horizontal force with respect to 0 to pi, P into d by 2 into dl into sin theta into d theta. So from where we got this? We got this from the, which is a vertical component of this force. Okay, so when you integrate this, which are the constants, P into d by 2 into dl are constants, and integration of sin theta is minus cos theta with respect to 0 to pi. Okay, so finally what you get? P into d into dl, right? So why? Because your cos theta is 1 by 2, so with respect to angle, right? So P into d into dl is your total bursting force which is acting on the vessel. Okay, I mean inside the vessel. So what is this d into dl? See, you can see it here clearly. This is your diameter, internal diameter of the cylinder, and this is your DL. D into DL will be the projected area of the curved surface. Okay, so which portion is going to be subjected to bursting? So the projected area of the curved surface, which is DL into D, will be your projected area which is going to be burst. Okay, so with respect to the pressure, P into D into DL. Okay, so now, so you have calculated the bursting force. Now what we are supposed to do for control or to resist this bursting force? What we have to calculate, Amma? So now you have done the bursting force calculation. Now what we have to do the next, for resisting this bursting force, we have to calculate the resisting force. Okay, can anyone tell me what will be the resisting force where your member is going to be in equilibrium? See, there should be some force which is going to resist this bursting force. So that force we call it as a resisting force under. Okay, so let us see what will be the resisting force. So the resisting force due to the circumferential stress will be 2 into sigma C into T into DL. Okay, how you got this? See, when your cylinder is subjected to internal pressure, okay, so like this. So from where the resisting will act? The resisting will act throughout its circumference. Avuna? So when you cut the section like this, if you see the section which is cutted in a form of a semicircular, okay, so you can see how this cylinder is going to be resisted. Your cylinder is going to be resisted like this due to the internal pressure which is acting due to some fluid or any gas. Okay, so resisting will takes place from both sides of the cylinder. So by that, your resisting force due to the circumferential stress will be 2 times of the cylinder into what is sigma C? Sigma C is your circumferential stress, and what is that T? T will be your thickness of the cylinder with respect to length of the cylinder, right? So by that, your resisting force will be 2 times of the circumferential stress into thickness into delta L. Understand? Okay, so this is your resisting force. One second. Have you all understood? Okay, so this is your portion which is going to be resisted with respect to length of the member. Okay, see, in earlier case we have calculated the bursting force. To resist the bursting force, you have to calculate what will be the resisting force with respect to its circumference. Okay, so which is 2 into sigma C into T into DL, right? So now to make that cylinder equilibrium, not to get burst, what we have to do? We have to equate resisting force equal to bursting force. Okay, so let's see what is the resisting force. 2 into sigma C into T into DL. What is your bursting force? P into D into, guys, if you are coming in between, it is okay, so 2 into sigma C into T into DL, which is equal to the bursting force, which is P into D into DL. Equate these two. So finally you can able to achieve your circumferential stress as P into D by 2 into T. Okay, so this is your circumferential stress. For any thin cylinder, your hoop stress or circumferential stress will be pressure into internal diameter of the cylinder by 2 times of its thickness. Okay, so this is your circumferential stress. With this formula only, you are going to calculate what should be the cylindrical circumferential stress not to get burst. Okay, if you want to control your bursting of the cylinder, you have to make sure your cylinder should have a resistance to this circumferential stress of P into D by 2 into T. Understand? So this is what about calculating the circumferential stress. Clear? Guys, have you all understood?
Yes, sir.
Yeah. So now immediately we are going to calculate what will be your longitudinal stress. Okay. See, longitudinal stress is also something like, where tension is going to make your cylinder to get burst in longitudinal direction. Okay. Let's see what will be the longitudinal stress. Let me delete this. Okay. So here you can see it clearly. There is a cylinder which is longitudinally placed. Okay, so there is a longitudinal, there is a cylinder which is longitudinally placed. So earlier we have seen the force which is acting tangential to its circumference, but now this force is parallel to its longitudinal length or longitudinal axis. This forces makes your cylinder burst on either ends anamata. Okay, so this is the longitudinal force. So to know this force, your cylinder should have a resisting longitudinal force also. Okay, so what will be the resisting force? From on either side you can see the resisting should be like this. Then only your cylinder won't get burst in longitudinal direction. Avuna ee resistance ekkadi nunchi vastundamma? Whatever the cap you are providing on both sides. Okay, this cap should have a resistance towards this force. What is this force? This force is a bursting force. Okay, this force is your resisting force. So now we have to calculate what is this bursting force and what is this resisting force. Equating these two, you can able to calculate your longitudinal stress, which is going to be acted due to the pressure inside your cylinder. Okay, so the bursting of the cylinder takes place along the section AB. So let us take a section AB along its length L, okay, or DL, right? Let us take a section AB. Due to this force, there is a splitting takes place in longitudinal direction, right? So now you can see, can you anyone tell me, sir, in which place your cylinder is going to split in longitudinal direction? Circumferential ga gaane kada split avutundi. Okay, see, this is your circumference of your cylinder. So this piece is going to be cut in two pieces, antena? Okay, there will be one piece like this, there will be another piece like this. So here you can see the circumferential failure in with respect to longitudinal direction. Okay, so ilaga manaki forces act avute. This is your longitudinal bursting force, okay, which is acting along its circumference. So now you can see it clearly. The force due to the pressure of the fluid which is acting at the ends of the thin cylinder tends to get burst, which have shown in the figure. Okay, so now our duty is to calculate what will be your bursting force and what will be your resisting force. Okay, so let's see what is your bursting force. Bursting force is acting along its bursting force a direction lo act avutundamma, along its circumference. Avuna? So by that, longitudinal bursting force on the end of the cylinder is gonna be P into pi by 4 into d square. What is this pi by 4 into d square? So that is your cross-sectional area of your cylinder. Avuna? Guys, is that correct?
Yes, sir.
Okay, so longitudinal bursting force is the pressure which is acting along its cross-sectional area of the cylinder. Okay, so this is your cylinder cross section. Okay, so this portion is going to get burst in longitudinal direction. By that, with respect to internal diameter, the area of the cylinder is pi d square by 4. Okay, why it is getting burst? Due to the pressure which is acting even in the longitudinal direction. This is your pressure. This pressure is making your cylinder fail in longitudinal direction. So by that, this is your force, bursting force, which is acting in longitudinal direction as P into pi by 4 into d square. ఎప్పుడైనా ఒకటే గుర్తుపెట్టుకోండమ్మా, your stress is equal to force by area. Your force is equal to stress into area. ఇక్కడ stress అన్నా pressure అన్నా both are same. Okay, so by that, force is equal to pressure into area. So your bursting force is equal to pressure into cross-sectional area of your cylinder. Okay. So now area of the cross-section which is resisting the force. ఇది బర్స్టింగ్ ఫోర్స్. మరి బర్స్టింగ్ ఫోర్స్ రెసిస్ట్ చేయాలంటే ఆపోజిట్ ఫోర్స్ ఎలా ఉండాలి? రెసిస్టింగ్ ఫోర్స్, యువర్ రెసిస్టింగ్ ఫోర్స్ షుడ్ బి ఇన్ ఆపోజిట్ డైరెక్షన్ కదా. సో విచ్ షుడ్ బి ఇన్ దిస్ డైరెక్షన్, isn't it? So this is your resisting force. మరి రెసిస్టింగ్ ఏ విధంగా జరగాలమ్మా? యువర్ రెసిస్టింగ్ షుడ్ బి హ్యాపెన్ ఇన్ టర్మ్స్ ఆఫ్ పై ఇంటూ డి ఇంటూ టీ. So this is your cross sectional area. So the resisting force cross sectional area is pi into d into t. What is this pi d? Can anyone tell me? Pi d ఏంటమ్మా ఇక్కడ? So this is your circumference which is 2 pi r. 2 pi r ని pi d అని కూడా రాయొచ్చు, అవునా? అంతే కదా. రెసిస్టెన్స్ ఏ విధంగా జరుగుతుంది? రెసిస్టెన్స్ is happening with respect to its circumferential. Then only we can able to control the bursting force which is happening in longitudinal direction. So pi into d is your circumference, into t is your thickness. This is your thickness. Okay. So this is your resisting force cross sectional area. Okay. Multiply this area with respect to longitudinal stress by why? Because as you know, force is equal to pressure by area. Pressure ante stress ikkada. Em stress ikkada? What stress you are going to calculate? Longitudinal stress. So your longitudinal stress of the material of the cylinder is going to be resisting force is equal to longitudinal stress into cross-sectional area of the resisting force, which is pi into d into t. Now what we have to do? We have to equate resisting force equal to bursting force. Andana? So simple amma. Bursting force is nothing but pressure into cross-sectional area of the cylinder, okay, which is in a circular shape. Resisting force is equal to longitudinal stress into resisting area. Okay, ఏ ఏరియా రెసిస్ట్ చేస్తుంది? Circumferential into thickness. ఇదే మనకి రెసిస్టింగ్ చేస్తుంది. So we are going to equate these two. So what we are going to achieve when you equate bursting force equal to resisting force? Let me erase this. Equate these two, what you will get? Pi into d into t into longitudinal stress equate these two. Pi into p into pi by 4 into d square is a bursting force. Sigma l into pi into d into t is your resisting force. When you equate these two, your longitudinal stress will be p into d by 4 times of t. Understand? So this is your longitudinal stress, right? Okay, so now listen carefully. So your hoop stress or circumferential stress is p into d by 2 times of t, and your longitudinal stress is,
sir,
yeah, tell me amma.
Oh sir, రెండు డెరివేషన్ వైట్ బోర్డ్ మీద చెప్పండి సార్.
Sorry,
డెరివేషన్స్ ఉన్నాయి కదా సార్, అవి ఒకసారి వైట్ బోర్డ్ మీద చెప్పండి సార్ మళ్ళీ.
See the same kada ikkada edaithe undo white board kuda meeda same kada. Okay, let me write it on white board. Okay, anu class జరుగుతుంటే ఏం మాటలు బయటికి. One second. Okay. See, this is your cylinder with respect to its length. Okay. So when the internal pressure is gonna act, it's gonna act on the circular circumference, I mean on the cylinder Let us take section XX here. If you cut the section, you can see it like this. Okay. So the pressure will be acting on its circumference, which is gonna burst your cylinder in this way. Okay, this is your pressure, right? So what will be your resisting force? Your resisting force should always be in opposite direction. Okay, so then only your cylinder is gonna safe with respect to the longitudinal burst, right?